Okay, we'll start. So, in the last session, I'll just summarize what we did. Do you remember what we did? Okay. So, we talked about interfaces. We said Java does not have multiple inheritance because of the deadly diamond, but it has the concept of an interface. In the last class, we also talked about what is an interface. We said the following. An interface starts with an interface definition, and in simple terms, an interface is like an abstract class with all methods marked abstract. First point. Second point, though we don't say it in the definition of an interface, all methods in an interface are public. So when you implement a class which implements that interface, then all the methods have to be marked public when we implement them. Point number 2. Point number 3, a class can implement as many interfaces as it wants. There is no restriction. Though it can extend from only one class, it can implement any number of interfaces. Point 4, I can refer to, using an interface reference, I can refer to any object whose class implements this interface. So these were 4 important points that we understood last class. Today what we'll do is, we'll go a little more deeper into interfaces. There have been some changes from Java 8 onwards in the definition of interface. We'll talk about why those changes were necessary and what are those changes. So we'll go step by step and understand. Now, but before that, a little more understanding of interfaces. So I'll just take you to a small example of how ambiguity can come with interfaces also and how you should avoid it. So it's not, remember we criticize C++ because it can create ambiguity when it can derive from 2 base classes and they will have the same method in both the base classes. So when you call that method in the derived class, the compiler doesn't know from where to pick up that method. Right? So that is what causes ambiguity. We saw that. Now what we'll do is, there is a provision for ambiguity, or there is a provision, but a possibility of ambiguity even with Java interfaces. So we'll see that just so that you know how to avoid it, and then we'll see how to make it happen. What I was talking about is the advancement on interfaces, but before that we will see a problem. Can we start? Day 8, program 1. Okay, so we will just create some dummy interfaces. Lab 1. Okay, day 8, not program 1, lab 1. Please open day 8, lab 1. Okay. Okay, we will start. Now it's important to understand what happens here, and please be typing with whatever we are doing, okay, so that you are current. I'm going to create an interface I, and I'm going to put 2 methods in it, void m1. Remember, even if I don't put public, it is understood as public, void m1 and void m2. Okay. So I'll create another interface I2. Let's call it IJ. No, don't call it I2. Let's call it J. So there is an interface J. Now it has void M3 and M1. Okay. And now we'll create a class, whatever, test, right? No, don't create test. Test we can create separately. Class A implements I, J. Implements I, J. And because it implements this interface I, J, it will provide body for 2 methods, 3 methods now. M1, we'll say M1 of A called. M1 of A called, class A called. Okay, and similarly we'll write M2 and M3. This is M1, this is M2, and this is M3. So we have a class A which implements Ij. If it implements Ij, it has two options. Either it should provide body for all the methods, or it should say I am abstract also. If I am abstract, I cannot be instantiated, correct? If it doesn't implement even one method of the two interfaces, then it can't do. So we'll write a main in which we'll instantiate A. So we'll say A small a is equal to new A. So we have instantiated A, and then on A we'll call all the three methods M1, M2 and M3. Okay. Now you have these three methods. Okay. Now we'll first see, what do you think? Will this work? There are two methods which are common. Sorry, not two methods. One method which is common, that is M1 in both the interfaces, and the class A is implementing all three methods. That is two from here, but one is common. So it is given a common implementation. Just see this once. Interface Interface I has two methods, M1 and M2. Interface J has also two methods, M3 and M1. So M1 is common between the two interfaces, perfectly fine. And the class A purports to implement or claims to implement both the interfaces, I and J, which is perfectly valid. I can implement any number of interfaces. Here I am not doing any delegation because I don't have a class to delegate the M1, M2 to. So I am creating M1, M2, M3 in class A and then instantiating A and then calling M1, M2, M3. So we will just run this and check whether this goes through or not. And if it goes through, then I will tell you what doesn't go through. So this, no problem. M1 of A called, M2 of A called, M3 of A called. There is absolutely no problem. Okay? Though one method is common. Okay. Now you will see where the problem starts. Is everyone having this code? Okay. Now watch what I am going to do. So go up. Okay. Now look at that M1 carefully. Okay. See, both interfaces have M1, and in this case, in this fortuitous case, or in this fortunate case, what do we have? Both the M1s are having the same name, which is okay, but they are also having the same return type, which I cannot insist because these two interfaces will be created by two different people. So there is no need or no specific requirement that the two M1s, though they are M1s, will have the same return type. Now, to understand what I am saying, just observe. So suppose I go to interface J, keep M1 as it is, but change its return type. Okay. I make it, let's say, int. Do you understand the subtle change I have done? The change I have done is, there are two M1s, one in interface I, one in interface J, but the variation is in terms of what do they return. One M1 gives a void, nothing, and the other M1 gives a int. Now, I want you to think about this scenario and tell me, will my code compile? Will my class A compile? Or will it compile? Obviously, most of you who are clear-headed and thinking will tell me that this won't compile because what? I have on line 10 an M1, but it happens to return a void. Okay? So obviously it won't compile because there is no other M1 which is returning an int. So first let's see this error and then try to solve it, and then we'll realize something. Okay, so we are compiling it. Now as expected, the compiler flashed an error saying that error M1 in A, the M1 in A cannot implement the M1 in J. Just see that error. M1 in A, the second one, M1 in A cannot implement M1 in J. Now you are understanding why that error is there? Because the M1 that I have in A has a void return type, and the M1 which is required to implement J has an int data type. Now, some of you who don't know Java well will do something like what I am going to do. Okay. Now, what you will do? Oh, the way the thinking will go, which is not correct thinking, you will say, oh, that is easy to solve. What should I do? I will create another M1 and make it return an int. Very simple. What great thing is this? Okay, so let's do that. So run that again. So we have now two M1s. Okay. Now, do you really think this will work? No, because we have now violated a cardinal rule of any programming language for that matter. What is the cardinal rule we have violated? Two methods can overload, no problem. Now very important point I am making. Please understand. Two methods can overload. That means they can have the same name, provided the variation is in the number of parameters or type of the parameters. No language in the world allows variation in the return type. Now we are asking for M1 and M1 to vary in their return type. That is not permitted in any language, not just Java. That's not permitted in C++, that's not permitted in C# or any other language you visualize. Java, Python, nowhere it's permitted that the variation is happening only in the return type. That is not allowed. So now we have a problem here, because now class A, though it seems to fulfill both I and J interfaces, the class A is itself illegal, because class A is having two M1s where the variation in the two M1s is not in the parameters or is in the type of the parameters. That is fine, overloading takes care of that. But the variation is in the return type. The variation in the return type is not tolerated, it's not permitted. Get that imprinted in your mind, because this is a common error people make. So now you will get an error, obviously. So let's see what the error is. It's a different kind of error. Okay, so now look at the error which comes. M1 in A cannot implement M1 in J. That was the earlier error. Last error now see. Those errors stay. Now you see the last error, return type void is not compatible with int. Are you with me? The return type int is different, the return type void is different. I can't have that. Okay? Did you catch that? So this is, if the interfaces stick to this, then I cannot implement both the interfaces. Try what I might. Because there is a variation, I am getting one M1 from here, one M1 from here. Earlier, both the M1s were of the similar type, both were returning void. I provided one implementation which satisfied both the requirements of the interface. Right? But now I have a situation, I have a dilemma where I have an M1 in one interface and I have an M1 in another interface. But unfortunately, though both are called M1, one has a void return type and one has an int return type. Now my dilemma is, in A, what return type should I have? And no language allows me to have the same function with exactly the same parameters and two different return types. Okay, this is not permitted. However, now I am going to go one level further and go into a little bit of intricacy. Suppose, can we go to the class? Yeah, suppose, interface, sorry. Now that void in M1, let's say, returns a float. Yes, returns a float, and the M1 in interface J, I will not touch it, returns an int. Okay, now can I make both the interfaces happy? I am asking, what do you think? Are you understanding what I am trying to do, or are you just sitting there? Think please. Can I satisfy both the interfaces? I have made a small change. One method is returning a float, one method is returning a int. Will it work? What do you think? Or if I say it will work, what should I do? What is the kind of M1 I should create? I cannot create two M1s with two different return types, right? So, what kind of M1 should I write? What do you think I should do? One is returning an int, one is returning a float. I want to satisfy both. What should I do? Return float, correct? I'll make both of them happy. Let's try. So, I will remove the two M1s. You remove one of the M1? Okay. Now, I'll make it public float. Okay. And let's try. Now, even this won't work. Why? Because float cannot become int. So, if I say int, will it work? No. Are you understanding? What is happening is, one of the interface M1 is expecting a float, and other interface is expecting an int. So, if I access through that interface reference which is expecting an int, it gives a float, there will be a narrowing problem. Correct? So, now observe this. I'll change it and ask you to observe again. So, let us change it to int. Line 10. Now, see what happens and then understand what is the logic. Now, error M1A cannot implement M1 in I, because M1 in I needs a float. So, I have tried all options. I tried to implement with two M1s, doesn't work. I tried to implement it with just an int and have that implementation. Just a float with that implementation. Nothing is working. So this is called the classic ambiguity problem. When does this come? This ambiguity problem comes if you are implementing more than one interface. Point 1. 2. Both the interfaces have a method with the same name and the variation is in their return time. So when that happens, we get ambiguity and we have to say that we cannot implement this interface, this pool of interfaces. This is a well recognized problem in Java and it is called an ambiguity problem. Okay? And this is an ambiguity problem. So you just have to keep in mind that when people say Java has solved all problems of interfaces and overloading and not, it's not true. Even in Java there is a possibility of ambiguity. This is the place where ambiguity comes. The ambiguity is coming because of the way the two M1s are created in the two interfaces. One is one return type, the other is another return type. And then we have a problem because we cannot satisfy both. Just keep that in mind. That is a very common ambiguity problem which we should just make a note of. Okay. Now let's go to more straightforward. The reason I wanted to point out this was basically because you should know this. Okay. Now we come to yet another idea of interfaces. I want to talk about when does a designer use interfaces and what is the big thing about this idea of interface. Now the idea of interface is not just there in Java, it is there in Python, it is there in C#, it's there in all languages which came after C++. Okay. But conceptually, what is an interface and where do you design an interface? For that, I often give the example of Ravan. You know Ravan? So why do I give the example of Ravan? Because Ravan also has 10 interfaces, 10 faces. Now, what is the meaning of each face of Ravan? I don't know whether all of you know that. Each face is supposed to be signifying different levels of expertise in different areas, correct? One face knows astrology, other face knows astronomy, third face knows statecraft, fourth face knows warcraft, fifth face knows music, and it goes on. It's listed somewhere in Ramayana. What are all the 10 faces of Ravan, what they do? Supposed to be very multitude of skill, what is called endowment of multitude of skill. And it's a very recognized story of how Ravan was. Anyway, our discussion is not on Ravan. But the point I am making is that there is one class, the way I want you to think of interfaces, whenever you think of interfaces, the reason I want you to think of Ravan is for this reason, that today, let's say I will correct that class, let's make it void M1 or int M1, whatever, and fine, let's keep it that way, right? Now, the idea of an interface is like this. Let's think of why we need the idea of interface and what is it. See, you have a class, right? Class has logic. Now, a class can have a lot of logic. For a particular type of problem or for a particular algorithm which works on that class or rather objects of that class, we need only some of the ability of that class. We do not need all the ability of that class. We need a certain ability of that particular class, and to use that ability, we define an interface and give it a name. You as a human being, if you realize, also exhibit multiple interfaces. You are a single human being. When you are at home, you are a family member. When you are at college, you are a student. When you are, let's say, on the cricket field, you are a sportsman. When you are with friends, you are a friend. So, as a person, there is only one. But you yourself realize that the way you behave in a college or in an educational institution and the way you behave at home, there are distinct differences. The expected behavior is different. The expected behavior here is different. Nobody will ask you to write an exam at home, right? No. Not really true, but whatever. So there are different behaviors a single class exhibits, but how to separate out those behaviors? The ideal idea is that of an interface. So you say, when I am at home, the interface that I present at home is that of a family member. The same person, when he goes to office, he presents an interface to the office which is of an office employee, of an employee. Are the behaviors different? Yes, they are different. Is the person the same? Yes. Similarly, it's exactly modeled on the same lines. Similarly, when a person creates a class, when a designer creates a class, it is not created with a single purpose in mind. It is created as a multi-purpose entity, and the multiple versions or multiple interfaces in different contexts which a class is encouraged to express is what are called various implemented interfaces. So, if I were to design a person who is an employee in the office, a citizen on the road, and a family member at the house, how would I implement it? I would say class person implements these three interfaces. Each interface, we will say, what is the expected behavior? The expected behavior of an employee is to do work. The expected behavior of a family member is to care for his parents or children, whatever it may be. So, these are expected behaviors. But that, it's like visualizing, and that's why I give the example of Ravan. It's like saying, I am all of that, but what do you want from me? Go and sit in front of that face. If you want astrological advice from me, sit in front of the face which can provide you astrology. Don't sit in front of the face which gives you warcraft, right? And if you want to fight a war, if you want to learn how to fight a war, come and sit in front of my war phase and interact with me through that phase. You will get my war talent or war machinery or war strategy or whatever I have to share, you will get that. It's exactly the same way you should think of a class and their relationship between interfaces. It has been beautifully crafted, and that's the reason why it's adopted in many languages, that this idea that I have multiple interfaces and a single body, a single class. And so what do you mean by this in a larger sense? When you design a class, I often give this example. One of the most important class in our companies is material. Material, as material, raw material, finished goods, whatever. I call it material. Now, the same material, one class is there. It exhibits different behaviors. You will say how? When an accounts department is looking at material, what is he interested in about the material? He is interested in how much does this material cost? How much can I sell this material for? That is what an accounts department is looking for. If I look at the same material from a warehouse or inventory perspective, my view is what? Is this material liquid or solid? How much weight is this material? What is the shelf life of this material? If I look at this material from a sales perspective, marketing perspective, I look at it completely differently. Who are the competitors who are making this material? How is my price compared to their price? What is the total number of sales done in North India for this material? He is interested in that aspect. But will you create multiple different material classes? Smart guy, what he will do? Say, entity is how many? In the database what exists? One material. But when you get it into the program and you retrieve that record from the program and convert it into an object, it should belong to a class which should have all these different interfaces. So this idea of interface is very important in design. So whenever you are asked to create a class, if you take my analogy further, they'll create an accounting material, then they'll create a inventory material, then they will create sales material, all of them separate and become a nightmare of maintenance, and because they don't know how to use object orientation. Interface, you have to, why am I spending time is, you should understand when should I create a class, when should I create an interface. When you are only encapsulating behavior, automatically there is no need to create a class. Class has to be created, and when a class is created, you must analyze what behaviors is it expected to give, standard behavior or in different applications. So how they design is, now I will give you a little analogy so that you will understand. When you design a database, you design material. And when you have applications, as I said, in any company there may be many applications running. Every application, when I say application, it depends on which part of the company this application is being developed. Like for example, even in our college, you see this campus. You are a student, you are the main class, right? But different people are interested in different aspects of you only, right? One part is interested in how you have got placed. Another part is interested whether you have paid a fee or not. Third part is interested, are you attending classes or not. Fourth part is interested, what other extracurricular activities you have done. These are again one student class. So in the database, how many classes are there? How many records are there? Only one, student. But when it is retrieved by different applications, the class which gets realized in Java has to have multiple interfaces, so that the same class, same data can be used differently by different people, because their utilization of the data depends on what they want to do with you. It is not dependent on what you are. So it is very important how you design this class and its interfaces. Maybe later when we bring JDBC, we will design a class like this with multiple interfaces and multiple algorithms. Each algorithm sees only one face of you, or maybe two faces of you, but not all faces. So one algorithm will look at only that aspect of you, and so it will interact to that class only via that interface, not through the other interface. Okay? So that is very important to get. Now what we are going to do is something very similar in our program. We have two interfaces, I and J. And we have one class, one solitary class, which implements both the interfaces, so it should have the behavior of both. Now what we'll do is, we'll go in the program. Now our class is okay. Come down. Okay. Now we'll create A like that, but let's drop 23, 24, 25. We'll remove. I'll show you what I just talked about. I'll say interface I, small I, whatever, I, equal to A. Is this correct? Can I do this? You're looking at the line I wrote. Is line 23 correct or no? Does it look correct? Forget whether it's correct or not. Does it appear correct? Do you like that line? No, yes. What do you think? Well, the line is correct. What is it doing? Look at the left hand side first. What is it doing? Just look at the left hand side. Don't look at the right hand side. What is it doing? It is creating a reference. What kind of reference? Interface I reference. What is a law? Remember, there are two laws with references. One is a base class reference can point to derived class object. We went through this a few days ago. Same law says what? An interface reference can point to any object of a class which implements this interface. So with that, if you look at A belongs to which class? A, capital A. Does A implement these interfaces? Yes. So is it a valid argument? Yes. But it comes with that caveat which I mentioned just now before I started this. Through I, what methods can I call on A? Only the methods which are part of the interface I. What are the methods which are part of interface I? M1 and M2. Only that I can, because I am looking at it only from that face. Now keep this in mind and remember what I said about Ravan. You can't go and sit in front of the astrology face and ask him questions about music. Correct? So now Ravan is A and I am sitting in front of it, but I am looking through it through interface I, capital I, through that reference. So I can only expect behavior defined by I to be visible or available through I. So if I say I dot M1, because M1 is anyway there, it will work. I dot M2 will also work because M1 and M2 are both behaviors of interface I. Let's just test them and check. Because it's a return int. Okay, fine. Think about it later. So, are you clear? This is allowed? Allowed, not allowed? You know why it is getting allowed this way, correct? Through I, that is interface reference, I am calling M1, I am calling M2. Okay? It's working. Okay. Now, I try to call M3 through I. Will it work? It won't even compile. It will say, what are you talking to? Which face are you talking? You are looking at the face I of A. So through that face, what can you do? You can only do M1 and M2. You can't do M3. So you'll get an error. Okay, let's see that error. Yeah, you can see the error there. So variable I is of type I. So it's saying method M3 is not available. Now please note, okay, let's go back to that line which is giving error, line 27. Look at it carefully. See, I is pointing to A. A does have M3 method. No, yes. Class A has M3 method. It is very much there in the body of M3. Body of A. But it is saying you are sitting in front of the wrong face. You are talking to me. You are referring to A only through I. But the face that which you are talking to me is an I face. I face allows only M1 and M2. If you have to talk to me for M3, you have to access me through my J face. Yes? So, this won't work, but you know what? Okay. Can you remove that line 27? I can say J small. I hope you are understanding this. This J is a reference, small J is a interface reference. Is equal to A. Will this work? Yeah, why not? If I sit in front of one face, I can sit in front of the other face also, no? Yes? So J is perfectly fine. J equal to A is perfectly fine. J I can call M1 because M1 is there in J also. I can call M3. Yes, I can call M3. Okay, let's run it. Okay. So you see there M1 of A called and M3 of A called. Did you understand now why interfaces are so crucial to understand? This is just the idea. This is an interface reference. Now, how did this idea grow? So we are now going to talk about Java 8, where till about Java 8 came along around 2004, 2005, maybe 2006. Till then, for about 10 years, Java interfaces looked like this. Then they slowly started realizing when people started using interfaces quite a lot, they realized that they have a problem. Okay. Now I am going to talk about the problem and then I am going to talk about the solution. Plus, please remember, the solution came only in Java 8 onwards. Like as languages evolve, people understand more and therefore they introduce more mature features. Okay. So one of the problems they discovered was we were using interfaces, we were using classes, people were referring to that interfaces. But at some stage, okay, now what happened is, can we go up? Okay. It so happened that with the change in technology, change in expectation, change and requirements of the programs which are using these classes, people felt that interface I should have one more method. Interface I somehow is incomplete. People started realizing that this interface I, which we have designed, let's say an accounting interface, there was a new change, a new policy of GST was created as an example. So some other rule, some other behavior which is now expected from this interface, which was earlier not expected, arose. Can you understand that situation? So far interface I, which was supplying, let's say, some information to the accounting department or some other department, said that, or if you say one more method in a warehouse interface got added, is this material hazardous or not? So this was not there earlier, but now the inventory requires to know, when it is talking to any material, the inventory application needs to know, is this material hazardous or not, which was not there earlier. When this requirement came up, what did people say? They said we have a need to create an interface. Need to expand an interface, that is add another method. Let's try and simulate what happened. So let's say somebody was looking at interface I and they said, look, I think I need an additional method in this interface. Let's call it void M5, whatever. Okay, now what happened? Now already this interface was there in this company for 10 years, let's say, and already a lot of classes were there in this company's software which was implementing this interface. Are you getting the picture? This interface has been designed, let's say, 10 years ago or 5 years ago, and there are many classes. Class A being one example, class B, class C, there are many classes which are doing what? Which are implementing this interface already, and they are using this interface. Now what happened? I said I need an extra method in this interface, M5. But the problem immediately started. What happened? All the classes A, B, C, which were hitherto implementing this interface perfectly, all of them broke. Broke means we can't compile them. Why? Because remember the requirement of Java? What was the requirement? A class has to implement all the methods in an interface or mark itself abstract. That was not acceptable because these classes were concrete classes. A, B, C, all of them were concrete classes. Now the problem came, what do? I want to expand that interface, but already I have a legacy of classes, existing classes, A, B, C, which are already in action, and maybe the people who created those classes and who knew what was going on in that class already have left the company also. Yeah. Or their code is too deep, too difficult to understand, and too much of work will have to be done in order to get this method implemented in that class. So, but my requirement still is there. I want to expand this interface. How do I do it? Now you can't change the classes. How many classes will you change? Suppose this interface is implemented by 20 different classes in this corporation. How will those 20 classes be made to change suddenly? Design another interface. But then if you design another interface, the classes have to re-implement it. It's not feasible. This is a big dilemma which faced Java after some time had passed, and which happens in any evolution of language. Now, at the moment, you will realize what happens. So let's see what happens. Okay, I obviously get an error which says, if you see it clearly, it does not mark the abstract and does not provide method M5. This is an expected error because I don't have method M5. If you added it in the interface after I was created. And the dilemma that I have now is, can you go up? Line 10, the class A you cannot change because it's a frozen class. In certain cases, you may not even have access to the source code of this class. It's a frozen class. Only bytecode is available. Only the compiled version is available, not the original version. What will you do? Correct? So then somebody thought of an idea. They said, okay, line M5, you want that line in the interface. Fair enough. You want M5 in the interface. Yes. Now you do what? You mark this method as specially default and you only provide an implementation. Now you will say, then what the hell? How is this? They said, whoever new classes are going to come, they will provide a body for M1 which will, not M1, sorry, M5 which will override your thing. But let the old classes work as they are. On them if you call M5, what will happen? The default M5 will come. If new classes are actually implementing M5, perfectly fine. But old classes will not break. Why will they not break? Because this default implementation will kick in. Now where will you provide this default implementation? You cannot provide it in A. You have to provide it in the interface itself. So they said they violated a cardinal rule of an interface saying interface can have a method, but if you want to have a body of a method, then you have to mark it as default. We'll give you a way out. That's why, if you recollect, in the switch case, okay, there is a default. Some of you don't know even that. Do you remember switch case? Switch case, the default. The objection which came was, default already exists as a reserved word there. Again you are saying default here. So they said the language compiler and grammar will take care of where default is getting used and accordingly adapt it. Sometimes you should make it a point to read some of these literature. What happens when a feature comes in? What is the turmoil which happens? It's all documented on the internet. Okay, maybe next time I will give you a couple of links which are true stories which happen in the software industry. Some of them will be mentioned on Stack Overflow, but some of them will not be. Okay, but they will be there. Okay. Now, what will we do? We'll mark that method as default, default M5, and I will provide a body for M5. System.out.println M5 of I called. M5 of I called. Yeah. So now I have an interface I which has two regular methods and one default method. Why is that default method? Because it was added later when they decided to expand that interface, and because there were already existing classes which did not have this M5 method, this interface had to supply a default implementation. Now you will see what happens. Okay. And then we will make some small change and understand. Go to main and say I.M5. I.M5. I am just calling semicolon. So we are calling that method I.M5, and it will work now, but it will call the default implementation. You see there, M5 of I called, because there is no M5 in A. No, yes. Do you understand why this was done? Now, we can change the same class. Let's imagine this was working and a new class B was going to get created. Okay? So, the class B could supply the definition of M5. Then its M5 will get called. If you don't supply an M5, then my M5 will be used. The interface M5 will be used. But if you are ready to give an M5, then your M5 will be used. So, either, okay, just copy all the methods, M1, M2, M3. Only thing is, copy M3 also. You are saying only implements I, then only M1 and M2. Okay, of B called. So now you see class B implements I1, but implements interface. But let's imagine that B came very new, very recently. By that time the interface had already changed, and now the interface had three methods, M1, M2 and M5. So B provides a body for M5 also, public void M5. And now we'll just say system.out.println M5 of B called. Okay, so we have that. Now, now see the variation. We'll go to main. We'll say I equal I1 is already gone. I1 equal to B is equal to new B. Okay. Perfectly fine. I1 dot M1, I1 dot M2 and I1 dot M5. Now you see which M1 will get called. Just watch. Yeah. So if you look at the code, in the first case, M5, look at the top one, M5 of I got called, and little later M5 of B got called. Are you seeing the difference? Because now class B is supplying M5. Therefore it is invoking M5 of B. Had it not supplied, then which M5 would have got called? Of I. Is this clear? So it is like a fallback. If you don't give it, I have my own method. This is necessary because interfaces cannot remain static. Static in the sense, same. Interfaces should be allowed to grow. The new classes which come can implement the new interface, have all the methods. But old classes which are implementing the old interface should also be safe. So these interfaces will supply default methods. Now going back to the interface definition, default has to be there. If you don't put the word default, then it will say you can't give a body. Body will be allowed only for default methods, not for any other method. So only when you mark a method as default, can you have more than one method? Yes, obviously you can have as many methods as you can, and you can write the body for those methods. Default. Because it's possible Today you expanded the interface with one method. Tomorrow you will expand the interface with one more method. Third day one more method. It will go on. So how do you handle this problem? You handle this problem by providing some standby definitions for those additional methods, and that is how this works. Okay. So we have one more idea on interfaces. The reason we are spending so much time on interface because it's very crucial that you understand interface, how classes work with interface, how do you refer to it, how do you expand it. Okay, there is one more idea which was again added in Java 8. The thing about Java 8 is, it is one of the few versions of Java which made significant changes. The earlier version of Java which made significant changes was Java 5. So from Java 1 to Java 5 it was by and large stable, some small changes. Java 5, Java 6, Java 7 stable, Java 8 again went up. There is a Java 11 which again went one more stage up. So that's how they pull up languages. Every 2-3, that is generally they say, every 6 years a language has to reinvent itself. Because if it ceases to do that, programmers will stop using that language. Why Java people are using even today? Language has to evolve. If the language doesn't evolve, language will die. Because programming is getting more and more complex. Requirements are becoming more and more complex. And if it's like saying, people who sat in this class 10 years ago, if they are as bad as you are, is it acceptable? No. You are as bad as them. I sent it the wrong way. It's not acceptable. Every batch should be ahead of every other batch, isn't it? They should code more, they should be more prolific, they should be more competent. Then only things evolve. Otherwise we are in retrograde. We are going back. So we'll move further. Now we'll introduce another idea of an interface called as functional interface. Okay, they introduced this idea again in Java 8. Actually, I'm not certain. Java 8 or Java 9. Okay, one of them. So the idea of a functional interface was introduced to facilitate two things. Method of a class, and why is it there? How are we on time? 12 work only. Okay. So we are done with by and large discussing about interfaces. We have seen what is an interface. We have seen why does a class implement an interface. We have seen how to extend an interface. We have seen the significance of an interface reference. And then we have to talk about the last idea of an interface which I want you to know, which is a functional interface. Okay, now I will tell you first of all what is a functional interface, and then we will talk about how do you use functional interfaces and what is their purpose. Okay, we'll I think start with a different example because it's a fresh idea related to interfaces. Okay, we have just switched to a different lab so that we start with a clean slate and discuss functional interfaces. Okay, now what is a functional interface? I'll start with a simple definition of a functional interface and then I'll talk about why is it so important to understand. A functional interface is an interface. The only rule it has to have is it can have only one method. It can have any number of default methods, but as far as method is concerned, it can have only one. Are we clear? So that is called a functional interface. Any interface which has just one method is called a functional interface. Okay, just one. Default can be any number. We are not worried about default methods, but non-default methods, there is only one. So interface I int m1. Is this a functional interface? Yes, no? Yes. Are all of you with me? It is a functional interface because it has just one method. It's called a functional interface, right? Okay. Now, how do I implement it? I'm now going to show you. Okay. Now, we'll write the main class. Watch. Okay, now I am going to use what is called as a lambda expression to define an interface. Okay, that is its beauty. Now you will see and slowly understand how do you define it. It need not use lambda, but if you don't use lambda, then you are not using functional interface the way it was meant to be. Okay, so I will say I equal to, just watch now, just open bracket, body, arrow, system.out.println, you can put bracket if you want. Now I think we should cultivate the habit of putting bracket. After that also semicolon. System.out.println or M1 called. M1 called. That system.out. thing is ending there. Now it's okay. Okay. Watch this. Do you see something strange? It's not strange. It is called a lambda expression. It's a short way of writing a method. I am providing a body for that method M1. Now you see line 6. Focus your attention on line 6. I think left hand side you understand. It's an interface reference. Look at the right hand side. What is there on the right hand side? Empty bracket. What does it mean? Because my method M1 doesn't take any parameters, I have put empty bracket. If my method was taking parameters, I would have mentioned the parameters there. But my method M1, you notice, is without any parameters. Okay? So the method M1 is there, and the body of that method M1 is coming through this. See that? The empty method and arrow, and then that is the body of the method. System.out.println M1 of I called. After that body there is a semicolon, there is the end of the flower bracket, and because this is a lambda definition, that last semicolon that you see is ending the definition. Now I can say on the next line, line 6, after line 6, I can say I dot M1, and that M1 will get called. Because, remember now why is it a functional interface? Because automatically it's understood that this method which I have given is a body for which method? M1. It cannot be anything else, because this interface has no other method. It has only one method, and whenever I am giving the body has two parts. One is the parameters and the rest of it is actual body. So now I will run this I dot M1. Just see what happens, and then we will understand it even better. It has a return type. Oh no, don't say return type. We'll do return type afterwards. Or you can put a return type. Okay, let's remove the return type for a moment. You can have a return type also, but we are not returning anything, so it's giving an error. Okay, so M1 of icon. Just please remember, I changed the type of M1 to void. Okay, so now see what I did. So this is a very convenient way of writing bodies for methods using this lambda expression. Now what is the lambda expression there? Whatever is on the right hand side of line 6 is called a lambda expression. Can it take parameters? Yes, it can take parameters also. If you want, you can supply parameters. You declare the method with one parameter or two parameters, a, b, a comma, int a, int b, int b, okay? And let's say this method will do an addition of a and b and return it. Return type on M1, line 2, int, okay? So I will say now, so I will say a comma b, or I can say L comma m, maybe that is better, L comma m, two parameters, and I will remove that system.out.println and say return L plus m, and I have a semicolon there. We need a semicolon there, inside, and then now I will say I dot m1 10 5 comma 10 and assign it to something, int k result is equal to I dot m1 and system dot out dot println result. Okay. Does everybody get this? Look at line 6 and understand line 6. What is on the right hand side of the equality is the body for the method m1. Do all of you get that? But it is supplied, the body is supplied kind of in a very funny way using what is called as a lambda expression or lambda definition. So what is happening is, when, remember the basic definition, this works with interfaces only which are functional, that is they have only one method. Okay, this is a functional interface, because otherwise it will be misunderstood what is this method body for. Now, and how do you create body in a lambda expression? Maybe just a couple of minutes to understand how do you do that. So, the way body is created in a lambda expression is, first you have mention, first you have parameters, I think I'll select this, parameters a and b, this is like parameters of any method, and then you have, so these are parameters and this is called the body, or some people call this head, which has the parameters, and this is the body. Body is generally in flower brackets, and you do whatever you are doing just like you write a body of any method, and a and b are the parameters. Now, do you have to declare the parameter data types? If you want to, you can, but it's not mandatory, because it will figure out from the definition of that functional interface a and b are integers, because it will look at the what is on the left hand side, see that a and b are integers, and you can treat a and b as integers. But nothing can stop you from saying int a, int b also. Don't have to, but it's okay. If you want to say it, you can say it. So, and then you write the body. And if that method is going to return something, be sure that you have a return statement here somewhere. This body can be any number of lines. But generally, we use functional interfaces when the body is very small, maybe 4 lines, 3 lines, something like that. When normally, again, no logic as to why you should have only 4 lines. You can have 40 lines if you want, but general preferred style. Now, you'll ask, why? What is so special? My other thing was okay, no? The way I was doing it just now, was it wrong? Was it bad? Okay. Now, let's see and compare. What does lambda bring to the table? Okay. So, okay, now normally if I were following the regular Java, the old Java, what I would have to do? I would have to create a class. Yes? I would have to create a class A or class B, whatever. That class would have to implement that interface, and I would have to write that. So, am I creating a class here anywhere? Do you see any class getting created? But you are still seeing a method getting called. So, something is getting created, right? A kind of an anonymous class is being produced, and on that class, that object of that class is also getting created. Not only is the class getting created, object of that class is also getting created, because if the object didn't exist, how did you call m1 on it? So, the method on it, I.m1. So now you compare it from what we did just a few minutes back, earlier example. I was equal to A. What was A? A class which was implementing that interface. Correct? And then I said I.m1 or I.m2, whatever. Did I just not do that? About 20 minutes back, I did that. Now I am doing, in the previous case. Now, look at this. Now look at this. Am I not doing something very similar? I am still saying m1. Yes, I.m1 I can do without parameters also. That's not a problem. But if you see, doesn't this code look more crisper, smaller, and does it achieve the same objective? No, yes. It is similar. It is just like creating a class A. Only thing is there is no class A. There is no A. And there is no class A implements I and then providing a body of M, and then I am saying no new A which creates an object of that class and then I call the method. It's not happening. All that is happening, but it is happening under the carpet, under the scene. It is happening behind the scene, right? It is all happening. A class is getting created with that method M1 and an object of that class is also getting created and I is pointing to that object. All of that is happening silently behind the scene. Now you have to develop that mind. So if I need only one class at any point which implements an interface, is this not better than creating a class, making that class implement? If I need, but in the whole of my design, I need only one class. Why should I go through creation of a class, instantiation of the class? This can do the same thing. But that is not the big power. That is a benefit. That is a side benefit. See, this lambda programming style. Now look at the right hand side. Just look at the right hand side of line 6. Think a little with me. This is a part of a very big change which is happening in recent computer science, last 4 or 5 years. What is happening is, earlier they used to say 3 kinds of languages exist. One language was like C, which was called a procedural language. There was no concept of class. Second category of language was object-oriented languages, to which C++, Java belonged. There was a third category of languages. Do you know which one? They were called functional programming languages. Examples of functional programming languages were, one popular example is a language called Haskell. Have you heard of Haskell? No? Not even heard? Anybody has heard of Haskell? Ears should be open. Okay. So there was a language called Haskell which was extremely popular. Okay. There was this language called Eiffel. There was this language called Haskell. These were extremely powerful. But you know what? They were not mainstream languages. Mainstream means, look, you don't know. Like that, many people in the community didn't know. But they had a power which was functional programming. Functional programming means ability to create functions into classes. It is also there to a large extent in JavaScript. JavaScript also has a very advanced functional programming story. But all this happened last 4 years, where the designers of Java and C++ started realizing, oh my God, we created object-oriented language thinking that this is the best language which we can create. But soon what started happening is, this functional programming, and I'll explain what is their value, started dominating. So what these languages did, every language has to survive. So what they did is, they realized this is a big threat. If I don't change, so what is the best way of surviving? Join. So they said, we will also start supporting ideas from functional programming. This lambda expression is one of the first ideas from a family of languages called functional programming, which got adopted both by C++, both by Python and Java, by everyone. All of them borrowed these ideas from functional programming. Otherwise I will not survive, I will die. Right? So, because a lot of programmers, especially who are influenced with JavaScript, JavaScript has a lot of influence of functional programming. So the guys who do full stack development and all that, why doesn't it support functional programming? They like the comfort. You will also soon start liking the comfort of functional programming. To write and code, I don't have to do all this class, these and all. I just put brackets, write the method, separate it by an arrow, and I am done. Why the hell should I write all this? So they got addicted to that. So obviously these C++ guys and Java guys started thinking, Arey baapre, these people are now getting used to this habit. So borrow it. So now you see huge influence of these functional programming. One of them is Lambda. I'll talk about other differences as we go through the course. But one of the major differences is Lambda programming. So it doesn't come to object-oriented naturally. It is a thing borrowed from functional programming into object-oriented programming. And that is how it. So one of the things it has done is this. But then you will say, Well, very good, it is from functional programming, but what's the big value? What is so special about writing it like that? There is a very big value there. Now, look at the right hand side. Again, left hand side is a variable or an object reference. It's an interface reference, but let's say it's let's call it an interface reference. Do you know the power there? Think with me. There's a huge power there. The right hand side, remember, right hand side can come from anywhere. Left hand side belongs to the program. I don't know whether you are. Think please. Traditionally in any language, left hand side comes from the programmer, right hand side comes from the external world. Yes? And I assign it to something and I read from the external world. Right? So, if you see this line 6 carefully from a different perspective, the right hand side can come from anywhere. No? Did it hit you? Line 6, right hand side can come from anywhere. It's a string which is being treated as a program. But if you look at it from a slightly intelligent perspective, what is on the right hand side? It's a string, which is special string. Can it come outside world? Yes, it can. Which means what? That logic, so far, object-oriented languages, once program is compiled, its data could change, but logic couldn't. Not getting? Try to get. It's important. See, when a program is running, the program is consuming data. Yes? But is the program changing? No. Object-oriented programs cannot change. Once they are written to do something like that, they are written to do something like that. Whereas, the beauty of functional programming is, the program itself is dynamic. Program can change as time passes. You have written the program. Its logic can change as time is passing. Why? The secret is on that line 6. Instead of hard coding that line, there is a way, and I will show you later. This line can come from a file, this line can come from the user, which means what? The logic I am taking from the user after the program has been written. So far, we are only able to take data from the user. Logic was permanent. Now, neither logic is permanent nor data is permanent. Logic can also be tampered, data can also be tampered. Data can always be tampered. But this beginning of functional programming, or this advent of functional programming into regular languages, what is it doing for us is, it is opening up a window of a completely different world, which is, I can change the program today to behave like this, same program tomorrow will behave differently. As long as I am having the ability to do something like line 6. Just imagine, right hand side of line 6 is coming from a file, from a user, from somebody else at some other time. Is it not changing the way it will work? So today, method M1's implementation is like this, tomorrow it is like this, third day it is like this. I did not recompile the program ever. I just supplied that line which it read and assigned. Okay? So, the important takeaway here is, please spend time on internet. Even Geek for Geeks has a very good treatment of Lambda programming. Lambda programming is a skill. We know, we should know. Part of that is here and you will understand as we go. Okay, so this was one idea which I had to introduce. Now, I don't know whether this is a right time to introduce one more idea, but I think we will not. It will get too heavy. There is one more idea which I wanted to introduce, that is of anonymous classes. This is also an anonymous class. But the traditional anonymous classes, how do they look? But let's not do it now. Okay? Let's give you some breathing time and then do it. Okay. So I think with that, we will do one example and we'll stop. I think we started one example yesterday, the last class, but I think that is a bit heavier. So we'll do that, jewels and stones. Okay, we'll do an easy program today, and let's see whether you can do it. So you just opened up so that you know a bit of programming knowledge. It's an easy one relatively. Day 8, program 1. We have done 124. Okay, let's see the solution. See one of them. Click any one. Okay, so here is, this is what I expected. This is fine. Okay, so for people who are struggling, first he reads the jewel string on line 5, then he reads the stone string on line 6, and then converts. You can take that as string or you can convert that into character array, nothing wrong. So you can convert it into, he has or she has, whoever has converted this into a character array, both of them, J and S. Then you go through each character I of J, and for each character of I of J, you go through each character K of stones to check if I, that is a jewel, is it a stone? If it is so, increase the answer by 1, and at the end print the answer. Okay? The variable names could have been named better than IJ, but otherwise it's okay. You go through each jewel, check whether the jewel is there in the string, and any number of times it occurs, add it, pick up the next jewel, see how many times it is occurring, and move on. Okay, so this is perfectly fine. Okay, we'll stop here.